Let's talk about HTTP. So HTTP is the hypertext transport protocol. So it defines basically how to serve HTML pages and other resources. So we've got a server in the cloud, and this is an HTTP server. And then we'll have some sort of client here, and this is normally your browser. So the browser sends a request to the server asking it for a particular page. And then, so what comes over here is request a page. And this is approximately the URL. Okay. And then what comes back is a HTML page. And then the browser client may need more information from the HTTP server or possibly from other HTTP servers in order to completely display this HTML page. So for example, let's say there's an image in this HTML page. So this browser client comes through, parse the HTML, and it's going to try and display, and it gets an image tag. Okay, so what's it going to do? Well, it's going to take the source, whatever this is, and it's now going to request that actual image. So an HTTP server can serve not just HTML pages, but also things like images as well. Images, JavaScript, style sheets, all those sorts of things, may have PDF files, any of that stuff. But the key is not that it only returns HTML pages. The key is that whatever it's sending and receiving is done using this HTTP protocol. So the image may go to the same server, or it could go to a different server. So if this source is a relative URL, then it would be on the same server. But if it was an absolute URL, it could very well be on a different server. So what happens? This HTTP server is actually running on normally. So if it's HTTP, it's running on port 80. And if it's HTTPS, it's running on port 443. So what happens is the client actually opens a connection. So if we've got some URL, and the URL is of the form, let's say http://host slash, let's say path, then what will happen is it opens a connection to the machine specified by the host, okay, on port 80. Why port 80? Because we had a HTTP scheme for the URL. And so that says by default it should be going to port 80 unless the URL itself specifies some different port. If we were doing HTTPS, it'd go to 443 and it'd also be encrypted. Okay. So it opens this connection to the host on that port, and then we'll go ahead and it's now talking to the HTTP server once it's got that port open. And this is a text protocol. So the protocol is going to be something like get. Okay, there are several different commands you can use. There's a get, there's a post, there's a handful of others, but get and post are the most common ones that are used. And so you say get, and then you provide the path. So whatever the path was, and in the old days, that's all you had to do, right? So what's happening is we're sending client, or the browser is sending this get/path. And then it also says what version of HTTP we're using. 1.1 is a common one, although there's a 2.0 now. Okay. And then the next thing we have to send is, it'll seem redundant, but that's the host name. Okay, so the host name is going to be the host from up here. The reason is that you might have a machine that is serving several hosts, right? So you have one HTTP server that supports multiple hosts. And so what you can do then is you can have multiple hosts that all resolve, so that is their host name resolves to the same IP address. But you still want different websites. And so therefore we go ahead and provide this information about what the host is. Because the fact is, this HTTP server is running. When we open a connection to host, what we really do is take the host, convert it to an IP address, and then connect it to that port. So when we first open the connection to the HTTP server, the HTTP server has no idea which host was actually used to get to this IP address. And so that's why you pass this host. And then, so we have to put a carriage return and a line feed. So this is kind of old-fashioned way things used to be done, but any text-oriented protocol on the web, SNTP, POP, HTTP, all use this carriage return new line approach. Turns out you can normally just hit 2 new lines, just hit carriage return twice, and that'll work for almost all browsers. And so what will happen then is the client sends this, and then the client receives some headers, which are all of the form, some header name and a colon and then a value. So it might be like, what's the length? What's the content length of this? Or what's the type of this? So that's how it knows it's getting back HTML versus PDF versus anything else, because it's not getting the file name necessarily. It doesn't use the file name for that. So we get a bunch of headers, and then we get the actual content. So this content is, in the case of an HTML page, this would be, the HTML page. Or it could be the bytes of the PDF, for example. So that's how the HTTP protocol works. It's really very simple. So it's gotten more complicated in 2.0, but in this 1.0, 1.1, in the 1.0 version, it was very, very simple in the sense that the client connected to the HTTP server, sent a request, got a response, connection closed. If it wanted something more from that server, it opened a connection again, sent a request, got a response, it closed. HTTP 1.1 added the facility where we can actually keep that connection open under the theory that if I'm a browser and I'm talking to a server, it's not just a one-time thing. I'm going to probably talk multiple times. And so we don't have to pay for the price of reestablishing the connection each time. For speed, many browsers would go ahead and make multiple connections to the same server, okay? Theorizing that we need to get from this server not only the HTML page, but also, as we're reading through, we're going to probably need to get style files, JavaScript files, bunches of images, other sorts of things. And so rather than waiting on this single connection to do that, they go ahead and open multiple connections. Today, HTTP 2.0 actually supports a protocol where we can have multiple simultaneous sending and receiving across a single connection. Let's go ahead and look at HTTP in go ahead and look at it live. Okay, so here we are let's just go ahead and try and connect to the hmc.edu HTTP server. So Telnet is an old program that will go ahead and just make a connection to a remote server. And so we're going to connect to port 80, which is the HTTP port. We go ahead and Telnet there, we go there, we're connected. Great. So let's just do a get for slash. So this is what would happen if we just went to hmc.edu, and we'll do the http/1.1. We'll tell the host is hmc.edu. We'll hit return twice. And what we get is a 302. So this is a return code that tells us what happened. So notice we got all these headers. So date header, server header, location, content link, connection, content type. So this is what tells us an HTML page, what character set we're using. And the 302 is a redirect. Okay. So what it says is we actually want to redirect to www.hmc.edu. Okay, so instead of just hmc.edu, it needs to go to www.hmc.edu. So the client actually would go ahead and get this response, and then it would issue a new request. So what it would do then is connect to www.hmc.edu, which is probably going to be the same IP address. And let's go ahead and look at this. So let's do a get. Host is www.hmc.edu. Hit return twice. And now it says, hey, you know what? This is another redirect. Okay. It's a slightly different 301 versus 302. I'm not going to get into that. But what we want to see is we want to actually go to https www.hmc.edu. So if we look at this, right, the difference is basically we were connecting to the insecure scheme, HTTP, and it wants us to be using the secure scheme, HTTPS. There's been a big push to try and make most pages go over these using a encrypted connection. So let's go ahead and see about that. So what we can do, unfortunately, Telnet won't connect to a secure connection. It doesn't know how to do that. So we're going to use something different. This is going to do the get that I typed, the get / HTTP 1.1, and the next line host www.hmc.edu, and then we'll have, so the echo will do a new line, and we'll have one more echo here to do an additional line. And then we will go ahead and put that into OpenSSL. So OpenSSL can go ahead and act as a client here. Connect. And what are we going to connect to? We're going to connect to www.hmc.edu, colon 443. We'll try and make OpenSSL a little bit quieter than it normally is. And I'm missing a double quote there. I'm not really sure why this has failed. So let's go ahead and just try to connect to a different host. And that's not good. So let's try. Let's try an example where we do connect to SSL. I'm not using HMC. So I connected via SSL to an example.com. Okay. And here I've got some information about SSL itself. So things about signatures, certificates, and so on. And then this is the response, which is 200. So 200, you sort of your everything is well response for HTTP. And so we have all this information. We have expiry information. So that tells us we can go and cache this page until September 5th. Tells us this hasn't been modified for the last few years. Tells us it's 1,256 pages. And now we see the HTML page. So we see the doc type. We have a head, a title. We have some meta information. We have some styling information. And then we have our body. And our body, we have our header. We have a paragraph. We have another paragraph that includes a link for more information to this page. So that is the essence of the HTTP protocol.